Yes, thanks very much, and thanks for the invitation. It's a great pleasure to be here, actually. And it's always good when you're not the first session up, because then you can build on the stuff that happened this morning and what Glenn just mentioned, and even just the session before lunch, I picked up a couple of things. That's why I did end up putting a few slides together anyway. I was sort of trying to basically pick on urban systems and drivers' challenges, solutions, and just one additional driver challenge that we haven't mentioned maybe as much as climate change and so on, and that's basically the urban population. So globally, we're already more urban than non-urban people, and it's growing rapidly, and the numbers are staggering. They reckon more than 2/3 of the population by 2050 will live in urban settings. So because of that, we have to look at what solutions can we provide in the urban settings. And so that's where some of these ideas and some of those elements that I'm bringing in are going to focus on. And when we talk about reuse, we tend to focus more about, let's collect all the water, all the wastewater, treat it, and then reuse it, whereas there is a lot of other alternatives as well. I'm not saying that's not a good option, that's definitely a good option, but there are others as well. And one of them is to integrate resource and water recovery. And what I mean by that is basically stuff that we currently sort of get rid of as much as possible, like nitrogen, phosphorus. They're actually a resource, they're fertilizer. We could use them. I mean, there are systems have been in place for many years, for decades indeed, to separate urine. I know it's not the topic after lunch, but anyway. We call it yellow water sometimes to be politically more correct. But there is 80% of the nitrogen that we're discharging is in that little stream. 50% of the phosphorus is in that little stream. And it's only 1 liter or 1.5 liters per person per day. But it's still 95% water, so we still have to do something with it. And there are ways of actually collecting that, treating it, and capturing the nutrients, using them, for example, in the houses, even for green walls and so on, using them for hydroponics, using them for fertilizer, for irrigation, for parklands and so on. And then you're reducing the demand on the water reuse for other purposes later on. So you could then treat it further to go even potable, or you use it for irrigation and so on. So that's one of these elements. There are similar approaches. For example, that's one I've picked up from the Netherlands, where they're separating the black water, which is basically everything other than showers and sinks. And they're basically saying, okay, there is a lot of nutrients, there is a lot of carbon in there. So you can capture, for example, methane. You can capture the energy out of that. You also capture the phosphorus and the nitrogen, so the nutrients come out of there. Then you mix it in with the grey water, because that's also polluted, but much less. And then you treat everything together, and then you do reuse. So you have these different ways of doing things in that space. And some of these things are being implemented. I mean, this is a picture of a project that happens in Sweden at the moment, where there's already 1,000 apartments. This is on the front there near the waterfront. And they're building, because the utility was so convinced about the solution and has now implemented it, they're now so happy about it, they want to build another development with 10,000 houses behind the city with the same system. So these are actually solutions that are being implemented already as we speak. Another approach, and we've been doing a lot of work in this space, is collaboration, trying to get solutions that are ultimately very appealing, so basically going for the acceptance, like Glenn said, but also looking at the water and energy savings and resource savings there. And this is a project that we've worked on very actively as part of this National Research Initiative on water-sensitive cities. And the point here is Southeast Water is a water utility, Willowood is a developer. Their business is basically doing property development, that's it. And they're collaborating on this, or have collaborated on this project called Aqua. And what they said is, we're looking at a total solution, an integrated solution. We need to deal with rainwater, stormwater, we need to have drinking water, and we need to figure out how we recycle water. And so they basically have an aim to reduce the drinking water supply by 70%. And they said, let's do it in an experiment, but the experiment is rather big. That's an actual development. This is it's just a map now. but it's actually been built. This is actually an old site where a wastewater treatment plant used to be, has been decommissioned and the pumping station installed. And the utility basically said, okay, let's use this as a demonstration site for new technology, for new solutions. And not just sort of a demonstration with one house. No, there is 420,000 square meters, 467 properties have been or are being built, and they're mostly finished by now, on this lot. And they all have a number of very interesting elements, and I'm not able to sort of cover all of them just for time, but a couple very interesting ones that popped up this morning when we were talking about rain barrels. We call them rainwater tanks, and Australia grew up on them because that was the normal way of water supply. But in this case now, all of the 460-odd houses, they have been provided by the utility with one of these black rainwater tanks, as well as the disinfection system and the hot water system. And this is a very high energy-efficient hot water system because it uses a heat pump, so they're using like 2/3 less energy than the normal electric system. And the rainwater is collected, treated through that UV disinfection, goes into the heat pump. There has to be there for at least half an hour at 60 degrees, blah, 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 in order to meet health regulations, and then is supplied to the house. And that's unheard of, that the utility actually provides each one of the householders with this system, and they keep it, and they own it, and they operate it. And the reason why they operate is actually because this rainwater tank has a second function, and it was mentioned, I think you mentioned it this morning as well, because they also have to deal with the stormwater. Stormwater is basically whatever runs off the roof and off the roads and so on. Now, when it starts raining, every hard surface runs off very quickly. So what they do is, when there's rain forecast, the utility, because they own the system, they have installed a little valve at the bottom of the tank that they can control from the central office. So it's a totally distributed solution, a decentralized solution, but it's centrally controlled. And so what they do is they open up all the rainwater tank valves, water goes down when it's not raining, so it's not flooding or whatever. Then they close them, and when it rains, the runoff from the roads or whatever can go into the stormwater system, and the rainwater gets captured in these tanks. So it's now a double solution, totally integrated between water supply solutions and also stormwater solution. And the additional benefit of having the hot water system for them was also that they said, well, we've got to deal with more than what we can control as a utility, which is your water supply and wastewater systems. And so basically they took note of that old report. It's now, 15 years old, or 20, almost 15 years old, where they looked at the total energy in the urban water cycle. And the energy consumption for what the utility controls is this bits. It's the water supply, it's the pumping, like the water treatment, wastewater pumping, and the wastewater treatment. That's 13%. The other 87% is the heating of the water at the household. So the utility now suddenly realized, hang on, we have much more control. If we save 2/3 of that 87%, we basically save more energy than we can save in the whole water system that we usually control. And it's this sort of secondary thinking that we've got to get to, where we start to look at sort of break down the boundaries and say, well, hang on, the householder doesn't necessarily need to deal with that, because the water utility can provide cold water or hot water. And how they make that is their problem, and I just pay for my water bill, and it has a cold water and it has a hot water component or something like that. So it's those sort of breaks that we have to think about. Anyway, so the outcomes of this, they're still working on it. It's not quite finished. They have some results, and they're getting close. But you see, they can create a 1 million litre storage on that site, which is all very densely, well, fairly densely sort of built up. They're also reducing stormwater. They're reducing the stormwater nutrient load because of that. Less runoff is less nutrients. And they're basically trying to aim to infiltrate more water and to reduce their potable water use considerably. But more about this was actually they're creating a very nice, sustainable and livable solution. And when they sold these lots, the first two auctions, they were basically They were all sold out within a few hours. And I think the second one, people camped outside the sales office the night before, so they would be the first ones in. So they were so keen to get onto this property. So basically, the take-home message is really, I think we've got to have innovation that is purpose-driven. Then it becomes most valuable, and then it gets used. We also need to take this in, as Glenn said, acceptance is everything. We have to have this socioeconomic consideration. So people need to accept it, but the money needs to matter as well. So the utility and the developer needs to basically make a buck out of it. But at the end of the day, the householder also benefits from it. And the whole of system integration and collaboration, to me, is key. These problems are so complex, so integrated, we cannot solve them by insulated type solutions. We've got to find solutions that actually address the whole problem in a whole of systems approach. So I hope that's a few ideas that we can take forward. Yeah, thank you.